Hello guys, welcome back to the video tutorial series of modeling reinforced concrete section in ABAQUS. So this is I hope the 8th video in the series that we are doing. In this video we will be going through the meshing of our model and also the different thing that we need to consider in our meshing. So if you are using ABAQUS for your research work, if you are a student using ABAQUS for research work, so it is highly suggested to do mesh convergence analysis first. So what does that mean? Actually, mesh convergence analysis is that when you assign different mesh sizes to your model and uh, run the analysis and get some results, and then compare the result of your model of different mesh sizes, and at the end you choose that mesh size which gives you the most accurate result. Either you can compare that result to your experimental data or some previous literature, or based on your own experience, or you can compare it to any other finite element analysis software result. But the basic philosophy of mesh convergence is that you just vary the mesh of your model. For example, you use the mesh at every single feet, or every single meter, or even every single inch, or after 6 inch, whatever suitable for you. And after that you can compare result, and whatever mesh size give you the best result, you can choose that mesh size. So this is called the mesh convergence analysis. So anyhow, first of all, before doing mesh, we can take a look at some mesh control. What are the available option, and what do we need to choose here? So you can choose different things here: beam, columns. Let's suppose if I choose beam and so it is structured mesh, hex structure. It's okay. If it is structured, it is okay. It won't give me too much error or this thing. But anyhow, these thing you need to play with these mesh controls. If you have, for example, any complex geometry, so perhaps the structured mesh will not appear, so you need to choose the other option at that point. Okay, so the next thing is that we need to assign the element type to our different thing. Let's suppose I'm using this, and it is 3D stress, which is C3D8R, which mean it is a 3 dimension with 8 nodes. Here the 8 mean nodes, which also it's mentioned here as well. An 8 node linear brick reduced integration hourglass control. So here we can select different kind of thing. One thing that I would highlight here is this element deletion. If you choose it by default, it means it's default, but if you choose it, yes, it means that whenever there is some spalling of the concrete, or whenever there is, for example, this concrete breaks and it's fall down, so you can observe this behavior by clicking this parameter. Yes, because you want to delete element from your whole model. Okay, so this is standard 3D stress linear and okay. And you can also, by the way, choose element type from the sets. For example, I can see the entire beam, the entire column. Let's go through each. It's 3D stress, it's okay. And element deletion I want is okay. Column rebars, continue. So now there's something important they need to highlight. When I was modeling my parts at a very first video, if you haven't go through previous videos, so I would highly suggest you go through the previous videos, and then you will come to know what's happening and why is this beam and something like that. So in my first video, I modeled my rebar as a truss element, but here it has selected beam as a default. So if I left it as it is and just run my analysis, it will give me error because I haven't selected a truss. We can scroll it down and here is a truss, which means T3 D2 element. We need to select truss element for our rebar section because I define rebars as a truss element. Okay, and next is column. We can see it is 3D stress, which means C3T 8R element. Okay, and we also have beam rebars, which is also by default selected as beam, but I want to select as a truss. Okay, and dismiss. Now that I have assigned my the uh, element type, the next thing is that we need to seed my part instant. So uh, during our assembly module, when I was creating the assembly, so I choose independent, the mesh independent, which means the mesh on instant. Why? Because now I can select all of my model at once, and then I can give approximate global size for the mesh at once. But if I choose at that time, if I choose the dependent, so now I need to mesh my beam separately, my column separately, my rebars in the column separately, rebars of beam separately, and also the stirrups of both sections separately. So to avoid that thing, I just, because it's not too complex geometry, so it's always good idea to have independent mesh on instant. Alright, so let's try first. I want my model to be meshed at every 6 inches, let's suppose. At every 6 inches, which means 0.1524. So 0.1524 apply, and okay, and okay, now I can mesh select instances, done. So now my model is meshed. Well, it seems a little rough mesh. It's want to make it a little bit, not too much, but a little bit finer mesh. So I think we can try it at every 4 inches, or maybe if we try it at every 3 inch, it will give me consistent mesh. 0.0762. By the way, you can also try with this kind of mesh. You can study the mesh convergence if you do this. Anyhow, I think it's a good idea to do it with this kind of mesh, because if I refine the mesh, it will give me it will take too much time for the analysis, and also my UDB file will be too large. So here now I have created my mesh. So now after that, the important thing to highlight is that in my previous video regarding the step module, I told that after meshing we will come back to our history output. So now I want some node set at which I'll be asking ABAQUS to give me some particular output. For example, I want the displacement or acceleration or something like that. So let's create our set, but I do not want any geometry. Let's make it a node set, and just name it, let's support nodes, or anything you can. When you click continue, so it will automatically change your model to mesh. So now it is up to you at which point you are interested in to get your result. For example, I want my, at this point you can press the shift key to select multiple points. Okay, let's, for the moment I only choose those 3 points. Okay, so now I'll come here to the history output, edit it. Instead of whole model, I'll select set, and then I can choose nodes. Although I have some other sets which is column, rebars and all these things. So if you are interested in the results of the entire this beam at each and every node, so you can also have that, but that is, time consuming, and also it is very difficult to get the result at any specific location. So also I because this won't take too much of your memory, so I suggest to keep it as at every n increment. By default it has this parameter, I do not want any of them. So at this point I want to get the, let's suppose, stresses in my direction, which is S22, and also the strain, let's suppose I need logarithmic strain, this one. I also want displacement in u2 direction, velocity in this direction, and forces and reactions, not exactly. Okay, anyhow, for the moment let's suppose, by the way you can choose many options, it also depends on your choice, what are you interested in, what do you want as an output. Okay, and dismiss it. So now I'm done with my step, and I'm also done with my mesh. Okay, the next thing is that when you're done with your mesh, you can submit your job. Here, just before submitting your job, save the model and also check the working directory whether it is the same that you have specified initially. So because it does not have any hunch here, let's suppose make it without hunch and continue. Okay, so we cannot use any space in the name of the job. So here another important thing that I need to point out is the parallelization. It means that if your computer or laptop has multiple processors, currently my computer have 6 processors, and sorry, cores, multiple cores. When you buy your computer, every computer and laptop has its own processor, and when you go to the details of that processor, you can find that how many cores do I have in my computer. So let's suppose I make it 4. This means that this will increase the speed of running the analysis 4 times, instead when you have just only 2. Okay, so and this is okay. So now let's submit the job and see what's happening. Okay, so my job is submitted and does not give me any errors initially. Okay, it gave me some error that a concentrated load on specified node assembly is not active in the model. Okay, so there is a problem with this point where I define my load. So I think instead of applying load at this point, it's a good idea to apply the load at some feasible location. So let's say we need to apply load somewhere here. So for that we need to have partition at this face. So we can do this from here, partition face sketch. So it asks us to select the face, so I want to select this face and done it, and select an edge. I can select this edge, so it will display this shape. So now I can take this tool and draw, let's suppose say here, and let's see how much. Okay, it says to, let's suppose I want to have the partition at 1 feet from this, so which means 0.3048. So this is now 1 feet and done it. So now you can see I have this partition. So now I can even apply pressure at this point, or even I can apply concentrated point load at this point, but for that I need to have a reference point which I can generate it from. First we need to have a midpoint first, which can be done from here. It asks us to select the first point. Let's suppose this is my first point. Select the second point. This is my second. So it generates a point in between these 2 points. Okay. Now from tool reference point, and can assign this as a reference point. Now let's try to create load at this location. Name it as vertical loading. Continue. Select this. Done it. Choose this, and how much was the load? 88,964. 88,964. Okay, smash it. Alright, so now because I have created partition in this, so the mesh is now deleted. We need to assign the mesh to this beam only. Okay, and it may also have disturbed our node set which we defined for our history output here. See, we only have one node here, we do not have nodes at this location, so we can edit it, and you can press shift key to add some other nodes. And done it. Okay, so now let's come back to the job and submit. So by the way, ABAQUS is a software that will give you error, and you will sort out that error, and after you came back it will give you another error, and then you will solve that issue, and then came back to analysis and it will give you another error. So this process will continue until you just end up. So it's now again giving me the same error that it's not available. So let's sort this out. So let's sort it out. Okay, I think I just remember that I need to define MPC constraint at this location to distribute the load that is applied to this point equally to this surface. So we can do that from here. MPC constraint, continue. It asks us to select the control point, so this is my control point, and select the region. So this is my region. Done it. And yes, the MPC type is beam. Okay, so you can see it distributed the load now. So now coming to my loads. Okay, so let's try this one. Okay, so our file processor is completed successfully, which means it does not give that error this time, but anyhow it will take too much time. So now we can see that analysis is running smoothly without any interruptions. So with increment 6.5, this is the total time step elapsed. And if you remember that I have given my time step as 1 second here, monotonic loading for 1 second. So it will continue until it reach to 1 second. So let's stop the video and wait for it to complete. Okay, so it is about to complete. By the way, you can also check details from here. So now it almost took 3 to 4 minutes to reach to this stage. Now you can see the status completed. Okay, it also gave me some warnings. Okay, that it doesn't matter. I just, when I was giving the request for my field output, so there are some outputs that are not available for particular type of element. For example, the T3D2, which is my rebars. So the compressive damage, tensile damage, these things are not available for my rebar section because I did not define any tensile and compressive damage for my rebar sections. So it's okay, it doesn't matter. Dismiss it, and now we can click on results. So here you can see, you can choose this option. Okay, so we will go through this in the next video, because there are a lot of things that I need to discuss. How to get different kind of results, how to analyze these results, how to observe different kind of things. So I'll see you in the next video.